Hello friends. So today we're going to start class 7 science chapter 17 effects of light. Heading, let's recall. When sun rays pass through a glass prism, what are the colors in the band of light seen on the other side of the prism? You have learned that light is composed of several colors. You must have also seen the dust particles in the beam of sunlight entering the house through a small window. We switch on the headlamps of a car when we drive through a thick fog. You might have seen the beam of those lamps. What do we really see when we see a beam of light? We see tiny dust particles floating in the beam. That is why we are able to see a beam of light. We see a variety of shades of color in the early morning and evening sky. In the photograph taken from the space by satellite, Earth appears to be bluish. What is the cause of all this? Heading, scattering of light. Subheading, try this. Bracket open. All the experiments using laser rays be done under the supervision of the teacher. Bracket close. Subheading, apparatus. Glass beaker, diode laser, bracket open, laser pointer, bracket close. Water, milk or milk powder, spoon, dropper, etc. Procedure: take clear water in a glass beaker. Pass a beam of laser ray through it. Check whether the beam is seen in the water. Now, use the water to add a few drops of milk to the water and stir. The water will be seen to have become slightly turbid. Now, pass the laser beam into it. Again, a light beam will show the existence of light rays. A light beam is not seen in plain water, but is clearly seen in slightly turbid water. The light rays hit the tiny particles of milk and get scattered. If these scattered rays enter our eyes, we perceive the light. Heading, try this. Instead of mixing milk, mix salt, sugar and detergent powder in separate beakers of water and observe what a laser beam is seen in them. When the sun rises, our surroundings appear illuminated. The entire sky appears bright. This happens because of the dust and other tiny particles in the air. This is the scattering of sunlight by tiny particles of the various constituents of air. Had there been no atmosphere, the sky would have appeared dark during the day, and of course, the sun would be directly seen. This has been verified by observations from the rockets and satellites which go out of the Earth's atmosphere. Subheading Apparatus. A table lamp with a 60 or 100 watt milky bulb. Bracket open. LED will not do. Bracket close. Thick black paper, sticking tape, a packing needle, 100 to 2 or 200 ml glass beaker, milk or milk powder, dropper, spoon, etc. Subheading Procedure. Cover the mouth of the lamp shade properly with black paper using sticking tape. Prick a hole of 1 to 2 millimeter diameter in the center of the paper with the help of the packing needle. Take clear water in the beaker. Light the bulb and place the beaker in contact with the hole. Observe from the front and at an angle of 90 degrees. Now add 2 to 3 drops of milk to the water and stir. Observe again. A few more drops of milk may have to be added to make the water turbid. A blue tinge is seen when observed along the 90-degree angle. This is the scattered blue light. Because the blue light is scattered, a red-yellow light is seen from the front and the whole appears reddish. Bracket open. Important. This experiment should be done in a dark room and by small groups of students. Heading: Use your brain power. If a few more drops of milk are added, the reddish color seen from the front becomes an intensive red. However, if many more drops are added, the reddish color is not seen. Why is this so? Sunlight is scattered by the molecules of gases like nitrogen, oxygen in the atmosphere. The blue color in the sunlight is scattered the most and therefore the sky appears blue. Sunlight reaches us through the layer of the atmosphere. At sunset, the light reaching us travels a greater distance through the atmosphere. Due to the greater distance, there is more scattering of the blue color. As a result, the red-yellow light reaches us directly and the sun appears red. Red light is scattered less than the blue light. Heading: Let's recall. What is a shadow? How is a shadow formed? Heading: The shadow obtained from a point source and extended source. Subheading: Try this. Subheading: Apparatus. Candle or torch. Cardboard, screen, small ball, big ball, etc. Take either a candle or torch as a light source. In front of it, set up a cardboard with a tiny hole, bracket opens O, bracket close, as shown in the figure. Now, light is seen to have emerged from a hole in the cardboard. Such a light source is called point source. Place a screen vertically at a distance of 1 meter beyond the cardboard. Hang the big ball between the screen and the cardboard. Observe the shadow AB of the ball. The rays OP and OQ, starting from the point source, just pass by the ball and fall on the points A and B on the screen, respectively. However, since no rays reach the screen between point A and B, that part still remains unlit. This is the dark shadow or the umbra. What happens if the cardboard with the pinhole is removed? Now, we do not have a point source. This source is called an extended source. What is the nature of the shadow formed by an extended source? Due to the extended source, we see two parts in the shadow of the ball on the screen. The faint part BC is called the penumbra and the dark part AD is called umbra. Let us see what happens in the following activity when the ball is bigger than the extended source. Keeping the distance between the extended source and the ball constant, move the screen further and further away and observe the shadow. As the screen moves further, the umbra and penumbra in the shadow of the ball are seen to become bigger and bigger. Now, replace the big ball with one that is smaller than the size of the light source. Observe its shadow on the screen. We see the umbra and the penumbra of the ball on it. Now, without moving the light source and the ball, move the screen further away from the ball and observe its shadow. As the screen moves further, the umbra becomes smaller and smaller, and at certain point it disappears. Heading Eclipses. Subheading What is an eclipse? The moon revolves around the earth, and the earth, along with the moon, revolves around the sun. Their orbits of revolution are all different. When the sun, the moon, and the earth come in a straight line, an eclipse is said to have taken place. Subheading Solar Eclipse. During its revolution, when the moon comes between the sun and the earth, a shadow of the moon is cast on the earth, and the sun cannot be seen from the part in the shadow. This is called a solar eclipse. Solar eclipse is seen only on a new moon day. The solar eclipse may be either partial or total. Sometimes the solar disk is completely covered by the moon. This is the total solar eclipse. When the solar disk is not covered fully by the moon, we have a partial solar eclipse. During a solar eclipse, ultraviolet rays, which are harmful to us, reach the earth. Solar eclipse should never be watched with the naked eye. A special type of goggles should be used for this purpose. Subheading Lunar Eclipse. When the earth comes between the sun and the moon, a shadow of the earth is casted on the moon, and a part of the moon is covered. This is called the lunar eclipse. A lunar eclipse is seen only on a full moon night. If the whole moon comes in the shadow of the earth, it is called a total lunar eclipse. When the shadow of the earth is cast only on a part of the moon, it is a partial lunar eclipse. You can watch a lunar eclipse with the naked eye. A lunar eclipse can be seen over a period of few hours. Note: for more information, refer to the lesson The Sun, the Moon and the Earth in the geography textbook. Box. Do you know? Eclipses often occur in the solar system. As seen from the Earth, when a planet or a star passes behind the moon, that state is called a occultation. It is a common phenomenon that occurs with the sun, the moon, or other stars. For example, in 2016, the star called Rohini was hidden behind the moon. After some time, it appeared on the other side of the moon. Did you see this occultation? Heading Find Out. 1. Time period of lunar and solar eclipse. 2. Various eclipses in the past and its relevant interesting information about them. 3. Eclipses and transits which will occur in the near future. Heading Zero Shadow Day. The day on which the sun reaches exactly overhead is called the Zero Shadow Day. On that day, at noon, shadows completely disappear. This event can be seen only in the region between Tropic of Cancer bracket open 23.5 degree north bracket close and the Tropic of Capricorn 23.5 degree south bracket close. This event occurs in summers on different days in different places in this region. Box. Always remember, an eclipse is a natural phenomenon. Many superstitions connected to eclipse are prevalent in the society. It is necessary that everyone makes efforts to rid the society of superstitious beliefs. Box heading. Think and discuss. 1. Discuss why it is not right to tie liventually to our car. 2. In our surroundings and in day-to-day life, we unknowingly believe in many such things. Is that right? Thank you.